So let me go ahead and show you kind of a little bit of the space we're going to measure here. So we've got a room. It's going to have 4 walls. We're going to measure around. You'll see we have a doorway here. We're going to have a cabinet that we'll take some measurements for. We'll go ahead and do a couple windows. You'll see some outlets. We're going to measure kind of a column here. And then we're going to do kind of a free-form curve in space, kind of show you some of the unique options of the system as we go along. So let me go ahead and minimize the video so now we can measure. So the first thing we're going to do is we're going to measure to set a plane on the floor. So we're going to take a point on the floor, and that will establish the floor as our active plane. So every 2D feature will get projected to that surface automatically. So we're basically going to create a floor plan. So I'm going to take 2 points per wall. Please note that the majority of our features, lines, arcs, circles, planes, can all do what we call best fit, which means you can take more than the minimum number of points per feature. I'll continue around, again, taking 2 points per wall. We see them drawn on the screen as we measure. And now what I'm going to do is just use some basic CAD tools to trim our corners. And then go ahead and show an isometric view. Maximize that. And then what we want to do, we want to be able to extrude this in space. So we're going to go into our measure tool, and we're going to take a point on the ceiling. And what that does is gives us a distance or depth from the active plane, which is the floor, to the measured surface, which is the ceiling. So it tells us 107.6. So we're going to tell it that we want to extrude everything. And we'll put in our 107.6. Okay, so now we have the basic room. And we're ready to go ahead and add some different features to that. So I'm going to come over here and identify an active plane, say on this back wall. And then go ahead and add some different features to that, potentially some of those windows. First, maybe what I'd like to do before I do that is go ahead and maybe create a layer. And in here, all the information is layered. So I'm going to come in here and create a level, and we'll call it Windows. I can also tell it that I want those to be a specific color. And now when I come in and measure those, in this case I'm going to do 2-point rectangles for my windows. I can also do 4 independent lines if I want to get more accurate in its whether it's truly rectilinear or not. And I can create another layer if I'd like. Oops, we're going to go ahead and create a layer called maybe outlets. Give those a color. Maybe we'll do it purple. And again, we'll go ahead and quickly grab some of the outlets that are on the floor here. Let me go into my rectangle feature, measure, and measure. Come over to another one, measure, and measure. Okay. So now if I want to go in and maybe add a cabinet, so let me come back in here, create a level. We'll call it cabinet. Give that a color. Maybe a dark green. And in this case, what I want to do is I want to set my plane back to the floor. And now I'm going to draw some lines along the edge of the cabinet. Just pointing the beam at the edge of the cabinet. You'll see this drawn on the floor, and then we will extrude it at its height. I'm going to go ahead and just zoom in on that area. And now I can go back into my trim, and we'll trim these corners and then extend the cabinet to the wall. And then we want to go ahead and measure the height of the cabinet. So I'm going to take a point at the top of the cabinet, and it tells me that it's 34.8. So again, I'm going to tell it to extrude, and I can say, let's grab everything in this window. And we're going to go 34.8. You can also go in here and remember in the corner we had the tube. It's kind of like a column. In this case, I'm going to show you our best fit capability, where we take more than the minimum number of points. So in this case, it's going to go on the cabinet level since I didn't change level, but that's okay. We could always change it later if we wanted to. So it draws that, and now we can measure the height of that as well. And now again, we'll go ahead and tell it to extrude. The 47.5. Okay. Now we're going to go in and measure that complex curve. But in this case, it's sitting at an oblique angle, and the system has capability of identifying a free-form plane in space. So I'm going to take points on this plane, and it's going to define that plane in space for me. We'll hit enter to say we're done. And what I'm going to do here is just tell it that I want to display the construction plane in the model. So you can kind of see where that created a plane. There's the XY plane in space. Now I'm going to go in and be able to create a 2D spline that will get projected to that plane in space. So I'm going to come along the surface, the front surface, and take points at whatever intervals I like. Another nice, unique feature of our system is the fact that we can take a free-form spline and automatically convert it to lines and arcs. Many times that helps in transferring the data to a CNC machine, which usually don't like splines, and takes away the need to do that manually. And I can get that surface as well. And if I want to measure that depth, I can measure that as well and actually extrude it in that space. And now just tell it to extrude the freeform curve. And in this case, we want to go negative 8.9. And so there's that surface in space. So we can always look at this in a rotated manner. It is all in 3D space. Now, something else is we've extruded this, kind of straight up. And what we want to do is we want to know, well, are these walls really plumb, etc. So I'm going to create another layer level, just called 3D points. And again, maybe give it a color. And I'm going to go back and measure some points, but in this case they'll be 3D points, so they'll float in space. And I'm going to measure these relative to this wall with the windows, and we'll be able to then evaluate those points to see how far they are from that drawn plane, so we know how much we need to shim, etc. So if I change my view to a top view and zoom in here, you can see obviously that these points float relative to the wall, and we're going to give us the true deviation of that wall in space, so we know how to shim, etc.